We are live, right? We're live. Okay, so let's put down some things that we already know. First of all, today's date, 10/12/21. Yes?
You gave Veronica algebra 2.
I did? How did that happen, Veronica? That's just no good. So sorry. And today we're going to talk about functions and their domain and range. So when you take a college math class, a lot of times this can be a really hard section when you do it. But if you can graph it, you can see it. With me? If you can see it, you can understand it. You guys with me? Because sometimes math is so abstract. But if we can see it, we can do it. So first of all, let's go through our definitions. Here's the function. Here's the definition I like. I like every element in the domain is paired to exactly one element in the range, okay? We're going to define our domain is simply all values of the independent variable. We put our independent variable always on the horizontal axis, okay? We call it the x-axis always. We just always x and y, right? But it doesn't have to be x and y. For instance, a couple of examples I already told you. One example, distance and time. If you drive 60 miles an hour for 3 hours, you go 180 miles, right? Distance and time. But it's your time that's the independent variable. You get to choose how long you drive. The longer you drive, the distance is dependent on that, right? Income. Now let's say the senior class sold tickets for $50 a piece, right? Income is dependent on the number of tickets you sell, right? So your independent variable would be the number of tickets you sell. And your dependent variable would have to be the money, right? So when we take a look at our range is all possible or all values of the dependent variable. The dependent variable is always on the vertical axis. So if you're going to talk about distance and time has to go here. You get to independently choose how much time you drive, and the distance is dependent on the time. So time goes here, the distance goes in, right? You're going to sell tickets to the senior class. The number of tickets, right, drives your sales. So your sales are dependent, or your income is dependent upon the number of tickets you sell, right? Does that make sense? And there's a lot of different examples we can take that are not X and Y. So then we know what the vertical line test is. If a vertical line passes through two or more points, it's not a function. Sorry it's so sloppy, you guys. It's funny, for 36 years I keep telling myself to try and learn how to write neatly, but I don't. I don't know what happens. Zeros. Okay, do you guys remember what zeros are? Anybody? Roots are correct. The what? Any value that makes the function equal 0. Very good. and they are also called roots. So it's any value that makes makes a function 0. Good job, Vince. Now, before we do number 1, got your phones ready? Okay. Now, what did Cookie Monster say when he's talking about girlfriends? What did he say?
That Jose has 0.
So if Jose has 0 girlfriends, what's going to be? It's going to be bad news, right?
Yeah.
Right, Jose?
It is.
Wait, wait. So, what value of x right here is going to cause Jose to have 0 girlfriends? -4. You guys agree with that? So if I graph this, let's just graph this and see what happens, okay? Got your decimals out. You're going to need parentheses to do it. So I'm going to go my Venmo, or not my Venmo, my Desmos. Wrong button.
No, you can know what he said.
Yeah, you want some money. I'm low on money. I was going to send Landon some money just to be nice, and I'm like, oh, I'm out of money. Okay, so I'm going to go y equals, and I'm going to go 1 divided by, and you got to use parentheses. Well, you might not have to use parentheses, but I like to use parentheses. X plus 4, okay? All right, what do you see? You know what's going on at -4? -1, -2, -3, -4, what's happening? It's going up to infinity and off to -infinity. So if Jose has no girlfriends, he's going off to infinity, right? Bad news. Right? So what's the domain of this function? What's the domain? Well, if I look at my graph,
Would it be negative infinity to -4? To positive?
you could do it that way. Actually, I'll show that way. That's really clever. I'm going to write it a little more easily, but I like your math. That's cool. So think about it. X values. Here's what Kai saw. Off to infinity, right? And off to all those x values work except for right there. So here is one answer I just heard. So I heard in set notation. I heard in set. So this is set notation, or interval notation. I heard negative infinity, comma, -4, and we'll say union, -4, comma, infinity. That's kind of what you said, Kai, and that was really good. Yes, Brittany.
Is that one, is the limit 0 or is it undefined? I can't remember.
That's undefined because you know why it's undefined?
It never reaches 0.
Okay, I don't teach calculus anymore, but when I do this, how I do limits. Watch the fingers. Are they coming to a common spot? Then you have a limit. It's that easy. No limit. That's calculus, okay? Okay, so then, I like this answer. X equals all real numbers except x cannot equal -4. Kai and I are saying the same thing. You guys see that? I'm glad you said that because I just helped a girl a couple of years ago with a pre-calc class, and this is the way they wanted it in her pre-calc class. It's much easier to write it like this, but this is the way they wanted it. So I'm like, okay, after you.
What is union?
Union, this and this, right? So you've got this set and this set.
Oh, okay.
Does that make sense?
So, united.
It's united. So we take both, right? Okay. All right, example 2. So real quick, right at the bat, what do you think on number 2 is the problem? So if I look at number 2, what's the problem? So if it's -5, x is -5, -5 plus 4 is -1. What about -4.1?
No, sorry, anything less than, not, anything greater than but not equal to -4.
Okay, how about -4?
That
I'm
would be
making-
0, so that would work.
So, keep saying you're right on
So,
target.
okay, so the value of x has to be less than -4, but it.
Greater than.
Greater than.
Greater than or?
Greater.
Because would 3 work? Or would negative 3 work? Would negative 3 work?
No.
Yeah.
Huh?
Yeah.
Yeah?
Would negative 2 work?
Yeah.
Would negative 1?
Yeah.
0?
Yeah.
So say it again.
Wait, but wouldn't it be less than since it's negative?
Well, how about negative 5? Is negative 5 going to work?
No. Yeah, no, it's not.
Right. And that's
Negative
less
5
than
is
negative
less
4.
than negative.
Yes, that's what I'm, yeah, I'm saying, yeah, x has to be less than negative 4.
It has
Greater
to be
than.
greater than, because negative 3 would be greater than negative 4.
No, I'm thinking, wait, can't it not equal negative 4?
Well, if it equals negative 4, square root of 0 is just 0, right? Okay. Now, what if we looked at the graph?
Sorry, I'm describing everything that doesn't work.
You were doing great. No, Lauren, you were doing great. You know what you were doing? You were thinking it through, weren't you? You should see me doing Spanish. I have to really think hard. Okay, so now let's look at the graph, right? If I look at the graph on my Desmos, come on, Desmos.
Old food.
Get rid of that. I could go y equals, and where's my square root symbol there? Square root x plus 4, right? And there it is, okay? This is a great example of why it's negative 4, though, because a lot of times you don't, we always take the opposite inside, right? And in set notation or interval notation, you could also write it interval. I like interval notation. I like interval notation. For me, it's just easier to write.
Oh, why is the negative 4 in bracket?
Great question. I was going to ask that.
Yeah.
Why do you think?
Because I honestly have no idea. Oh, it's equal to.
That's why I use bracket. If it equals it, use bracket. And then here's another one, Vince. Why is this in parentheses?
Because it's continuing.
Can't get to infinity, can you? It will never equal infinity, right?
Oh, okay.
See? Come on, thinking today, aren't we? Love it. It's awesome. Okay. Okay, now, what about example 4? Let's graph example 4 and see what happens. Okay, let's just graph this one. And y equals, and you're going to have to use parentheses twice. Parentheses x plus 2. Oops, back up. Oh, my goodness. Okay, graph 3 and see what happens. Get rid of that. Yeah, graph 3 and see what happens.
Whoa.
Did you get it?
Whoa. Yeah.
Cool, huh? What is it?
It's a half circle.
It's a half circle, right? And what's the radius of that half circle? I bet you can guess. Three. Because what's the square root of 9?
3.
3. So it's a half circle, isn't it? Right? So what's the domain? What's the domain?
The x is less than or equal to
Yeah.
And greater than or equal to negative 3, isn't it?
Yeah.
So
Okay.
in set notation, you could write it like this, okay? You can go negative 3 is less than or equal to x, which is less than or equal to 3. That's set notation. Or interval notation. I think you're going to like interval notation better when you finally get the hang of interval notation, right? And that makes sense. It really does. If I were to put in, okay, use your brains. Put 4 right here. 9 minus 16. 9 minus 16. Negative number, right? Negative 4. 9 minus negative 4 squared is positive 16. 9 minus 16, negative number. Can't be squared, okay? Kind of cool, huh? If you can see it, you can do it, right? Okay, now let's take a look at the next one, okay? Get rid of that. Let's see if we can graph that one. Okay, parentheses. You're going to need parentheses. X plus 2 parentheses divided by, you're going to have parentheses here. Go ahead and type it in and see what you get.
You could also do the algebra first.
Mm-hmm.
positive 4.
Did you do it? Okay. Did you get this?
This is what I got. Did you guys get that?
So, Doreen, it seems like it's got a problem. Where's the problem at?
Huh?
4, right? So 4 is a problem. There's another problem. There's a second problem. I know.
So 4 is a problem, and I'm going to type on -2 for a second. Oh, there it is. I saw it. Hold on, wait now. Oh, I had it for a second. Oh, there it is. There it is. Can you see it?
Yeah.
-2. Come on. It is. So why is 4 and -2 undefined? Well, can't divide by 0, right? So if by chance I thought, hey, I'll just factor this. Right?
Okay. Now remember, Jose cannot have 0 girlfriends. Right?
Right.
If x is -2.
It's impossible.
If x is -2, it doesn't exist, right?
0.
And if x is negative, if x is 4 here, so these two, 4 here gives you 0. Divide by 0, Jose has a girlfriend, is bad news. If -2 here for x, right? So I just factor that, right? This one's what we call removable. I'll say it again. This one's removable. Why am I saying this one's removable?
It's the same thing.
I cancel, right? That one's removable. You guys agree?
Yep.
If it's removable, it's a whole. If it's non-removable, it's an asymptote.
What?
Yep, an asymptote, right? Sounds bad, doesn't it? There's a lot worse words in math, believe it or not.
So if I do this, I just want to look at the graph real quickly. So the graph has a hole in it.
Is that why it's all in Desmos?
Yeah, and you won't see the size of the hole because it is infinitesimally thin. Okay. All right. So,
If it's removable, it's a whole. Okay, now, are you listening?
Yeah.
Negative 1.99999. Negative 1.99999 will work. Negative 2.000001 will work. Negative 2 doesn't. So the size of your hole is, watch it, that y. Your hole is infinitesimally small. Because we could go negative 1.99999999999. That'll work, right? So you have a hole. The hole is this way you'll never see it on a graph. I have to make it that big so we can see it, right? This one's non-removable, that's why you nest it, okay? Now, Brittany,
Yes.
that's a limit. And the answer is whatever the corresponding y value is, right? Which would be, give me a second, negative 160, okay? Do you see that? That one has a limit, the other one doesn't.
okay, now, how about number 5? Let's graph it. I'm going to put it on this one. I'm going to put it on this one because there's something I want to show on this one. Clear. 7 divided by square root x subtract 1 window 5. Okay, you guys got it? Graph. Oh. Gonna have to make it bigger. Window. Okay, did you get this graph right here?
Something like that? Okay, so what can x not be? What can x not be?
1.
Can be 1. Look what happens with 1. right? And nothing back here either. Why not nothing back here? Could it be 0? Well, what? It can't be 1 because what happens if it's 1? 1 minus 1 is what? And then Jose's sad, right? But you can't have negative square roots either. So this, what's the domain? Think about it. What's the domain of that one? But not equal this time. So I mean, it's bigger than 1, right?
So x is just greater than 1. So we're going to write that down. X is greater than 1. Interval notation, which I like, is going to be 1 comma infinity. And Vince, you can see why I didn't use a bracket, right?
Yeah.
How about this one? You want to see how to do this one in interval notation? This one's wild. We go negative infinity, comma, negative 2, union, negative 2, comma, 4. Here's interval notation on this one. Union,
Oh boy.
4, comma, infinity. How's that for interval notation, huh?
That is a chonker.
Or I would just say, to make it easy,
Real.
all real numbers except. I'd say x equals all real numbers except x cannot equal 4 or negative 2. That's easier to write that one than interval notation.
Does the, what does the I stand for? Is that like except, or is the equals with the?
Oh, it's equals with a slash through, meaning it can equal this, but it cannot equal these.
Okay, then what's the I?
Oh, it's a semicolon.
Oh, it shouldn't be an I, but, oh, that's a semicolon.
Oh, it's semicolon, okay.
Yeah, sorry. I know, like I tell myself, are you younger to be able to leave your hand? No, it never happens. Okay, you guys getting the picture of what domain and range is? Okay, what can X not be, right? Okay, turn the page. And I'm taking forever to teach today, but I'm having fun. Graham, Washington. I think I'll let that one go. I don't know anybody in Graham, Washington.
Answer it and cleanse them.
Message.
What am I doing?
Sorry, I can't talk.
Oh boy.
Okay, 6. Okay, now an absolute value graph, and I don't know if you guys remember that or not. It's been a while, is a V. Okay, and it looks like this. It's going to be at negative 3, the vertex will be at negative 3, negative 4. Here's our graph. Okay, everybody okay with that? And now you really know why it has to be negative 3, because negative 3 is the value that zeroes it out. Negative 3 is the point that zeroes out, and if this is 0, it drops down to the bottom point. I'll say it again. It has to be negative 3 because negative 3 would allow me to get the smallest y value, correct? It makes that a 0. Now, domain, what's the domain? All real numbers, yes. I agree. Domain, x equals all real numbers. What's my range? Range is going to be y is greater than or equal to negative 4. Good job. Well, now what about zeros?
Indeed, where it's the x-axis.
There and there, right? So my zeros are at x equals 1 and x equals 1, 2, 3, 4, 5, 6, 7.
How would you figure that out with mathematics?
Great. We would say 0 equals x plus 3 minus 4.
Oh, and then you just solve it with a negative.
Right. And when you get to here, there's always a positive and a negative value for absolute values. So you'd say 4 is equal to x plus 3, and you'd say negative 4 is equal to x plus 3. Great question. Okay. And then obviously here you're going to get our 1 and our negative 7, right? Good question. Now, piecewise graph. It's been a long time. You guys remember these at all? Okay, they're not that hard. First of all, let's go back to this. Start here. On the x-axis, I'm going to go to negative 1 and put my invisible borderline at negative 3, my invisible borderline at 2, my invisible borderline and at 5. So it's called piecewise graph because we want pieces of it. It's called a piecewise graph because we want pieces of it. Well, we want a piece of it here, a piece of it here, and a piece of it here. Okay? It tells me where this piece goes. It tells me where this piece goes. And it tells me where this piece goes. Okay? So I start here. I put down my boundary so I know where each piece goes. Thumbs up? Okay. Then, let's look at all 3 graphs. We're going to have 3 graphs, but we're only going to put them in their spot. So the first graph, we got graph 1 is just simply a y equals x. Well, I can graph that. Start at 0, up 1 over 1, up 1 over 1, up 1 over 1 over 1, up 1, right? Got it? Except this piece only goes in here. This piece only goes in here, so we erase all the rest, because this graph is between -3 and -1. Do you remember doing this at all?
Yeah.
Sorry, no. We're going to erase it. Oh, Alex, we did this, but it's been a long time, huh? So I'm going to erase. Okay, erase all the other parts of it because I only want the piece that's within there. Okay, now I'm going to do this. Solid dot, open circle because it doesn't equal -1. Now, second graph, x squared minus 1, goes in my other piece, right? So how does that graph look? Well, it's a parabola, I know that. So graph number 2 looks like y equals x squared minus 1. Start at -1, up 1 over 1. It's going to be a parabola 1, 2, 3, 4. Here. Here. So it looks something like this. Okay. Except I only want the piece of this graph here only. I only want this piece of it right there, okay? So this graph only goes between -1 and 2, so erase all the rest, okay? How am I doing? You guys remember seeing this at all? We did it in geometry.
I remember geometry.
I know. You didn't have me for geometry, did you?
I did.
You had me for geometry?
I just for all 4.
Oh, you did? Oh, man. Okay, well, then it's my fault.
No, it's not.
It's okay. I'm going to stop there and erase this, okay? Solid dot, open dot. Solid dot, open dot,
So
okay?
you start at 0?
That is.
Oh, no, I got to come back up here. Carly, thank you. Carly, I made a mistake, but you didn't, did you?
I didn't.
You did not make a mistake, but I did. So thank you, Carly. Carly, it goes like this, doesn't it? Thank you, Carly. Okay, last graph. I've got a y equals 2, and that's just a horizontal line at 2, right? But I don't want all of that, right? So I'm going to erase y equals 2, right? Y equals 2, but I only want this piece of it, right? I don't want all that. I just want this piece because it says only between 2 and 5. Okay. Do you remember this now? Is this coming back? Okay, good. I saw one thumb up. Thanks, Lauren. Well, one's better than none, right? So I'm going to go like this. Close circle and open circle, okay?